Hello, and welcome to Building Hadoop Clusters. My name is Sean Mika, and in this video series, we will teach you all about the technologies so you can use the cloud to deploy your own Hadoop cluster. In this section, Section 1, we will be talking about deploying cloud instances for Hadoop. This section covers 6 key areas of what you will need to understand cloud technologies, and also what you need to get started on installing Hadoop. Specifically, in this video series, we will cover the first 2 sections. In this video, Video 1, we will cover the introduction to Amazon Cloud and usage for Hadoop deployments. We will also cover navigating the AWS and EC2 dashboards. So let's get started. First, you want to understand what cloud technologies are and what we will use in this video series. For cloud technologies, when we talk about cloud technologies, we talk about different services that provide computing resources where you can pay as you go. Typically, you can access these servers over the internet, and you use those servers you rent to install any type of software you want. There are different types of cloud services such as IaaS, or Infrastructure as a Service, PaaS, or Platform as a Service, and SaaS, or Software as a Service. Generally, IaaS refers to the hardware resources and the operating system. PaaS includes the platform on top of IaaS, such as a database or other development platforms to create applications. And SaaS sits on top of PaaS and is the actual application you interact with. In our video series, we will use Amazon EC2 as an IaaS, and we are specifically going to look at Hadoop. Hadoop is an open source framework. You can download Hadoop from free and run across multiple network commodity servers. What we mean is Hadoop has the ability to take a single file or multiple files, and it will automatically spread those files across multiple servers. This is known as HDFS, or the Hadoop Distributed File System. Secondly, Hadoop will allow you to run code, and it will manage the process execution of that code across multiple servers. This programming model is known as MapReduce, and we'll talk about how MapReduce is used to process data where it resides on each one of those servers, so we can scale out the processing across multiple servers in the cloud. Specifically in this section, we want to talk about navigating AWS and the EC2 dashboard. And for the cloud technologies we will use in this video series, we are going to be using Amazon. You can access the Amazon Cloud at http://aws.amazon.com. Point your web browser to the Amazon web address for the cloud, aws.amazon.com. If you are a new user, you will need to sign up with your email and password. And also use a credit card, because that is how you will be charged by the hour to rent your different cloud instances. Once you already have an account, go to the My Management Console and the AWS Management Console, where you'll be able to log in with the user account you created if you haven't logged in already. Once you're logged in, you will be able to see the components you have in the Amazon Web Services. Specifically for this video series, we will be using EC2. EC2 is where you'll be able to rent virtual instances in the cloud. If you click on the EC2 link, instances from AWS will be shown, and you'll see the dashboard for EC2 and the running instances. Here you will see that we have 3. Other features about those instances that are running are what volumes are connected to the terms of data, what the key value pairs are in terms of security, and other areas like elastic IP addresses that allow you to assign specific IPs to servers so that they stay constant. Security groups are there, and you'll need to define these for your network ports, which will be open. If you click on any of the components on the dashboard, it will allow you to drill down and see what you have running and know exactly what is happening for your Amazon EC2 instances. So to summarize, we learned what cloud and Hadoop technologies are and how to navigate those and get started on the AWS and EC2 dashboard. Coming up in the next video, we will describe how to deploy Linux AMI or Amazon Machine Image, along with choosing the correct setting to install our Hadoop instances. Hello, and welcome to Building Hadoop Clusters. This is Section 1, Deploying Cloud Instances for Hadoop. In the previous video, we talked about how the Amazon Cloud and Hadoop instances work. We also navigated the AWS and EC2 dashboard. In this video, video number 2, we will be talking about how to choose the correct Linux Amazon Machine Image, or AMI, and also how to deploy the AMI and choose the correct settings. When we talk about choosing the right Amazon Machine Image, we must make sure to choose the AMI based on the correct operating system. The operating system is going to be determined by the Hadoop requirements. For this video series, we will be using the Hortonworks distribution of Hadoop, or HDP, Hortonworks Data Platform, version 2.0. There are other distributions of Hadoop such as Cloudera and MapR, as well as others. Each differs to their approach to Hadoop. However, all are committers back to the open source distribution from Apache. We chose HDP here as they are completely open source and only run on top of Apache components. As well, there is no cost to their software licensing model. We will see that version 2.0 of Hortonworks Hadoop distribution requires CentOS Linux, 5.x or 6.x, 64-bit. So we recommended the AMI version listed here to be used for the video series to install your underlying Hadoop clusters. Well, let's see how you would determine to choose the right AMI image on your own. We do that by going to the Hortonworks website. So if you go to the Hortonworks website, you can take a look at their products and see that we want to install HDP2. If you click on that, you can see that you can download and install that version, and you can get documentation. You'll also see that CentOS is an accepted version or operating system for this Hadoop. But we want to specifically look at the installation documentation for what version of CentOS we should use. So if we click the documentation, and then we look at the install documents, click minimum system requirements, and here you'll see that we have CentOS version 5 or 6x 64-bit is a recommended version. You can also see what other versions there are to install your Hadoop software on. Once we have this information, we want to go to the Amazon Cloud, or AWS, and log into our account so you can launch an instance. So I'm going to go ahead and go into the EC2 dashboard. Once I get into the EC2 dashboard, I want to click on Launch Instance. I see that here. Once you click the Launch Instance, you will see all the different options you have for creating an AMI image. We are specifically going to select Community AMI, because we have many options on the versions. You're going to see that we want to select the version of an operating system that's going to meet our Hadoop system requirements. And since we have recommended an AMI for this video series, we're going to choose that here. We'll see what comes up is the CentOS 6.2, 64-bit, and we click on Select. Next, we want to choose a large instance, which includes 2 virtual CPUs, 7.5 gigabytes of memory, and about 800 gigabytes of data space. Large EC2 instances currently cost about 24 cents per hour on March 2014. Choosing the right size instance is important because we want to make sure we have enough processing capacity to install Hadoop. We have had problems with installing in the cloud on smaller instances, but you may try yourself. You may get some timeout errors if you do. Next, you want to choose configuration details. We want to create 3 instances, so for the number of instances, we choose 3. We use all of the default settings, EC2 Classic Network. We click on Next for Add Storage. You won't have to add any storage here. Right now, we know that each of the AMIs comes with its own storage. Keep on clicking through to Security Groups. Let's create a new security group, but we will deal with the details later. Just give the security group a good name like Hadoop Security Group, as we have done here. Next, you will click through and go to Review for launch. You will see your AMI details, double check instance size and number of instances. Check the rest and don't worry about any of the warnings after you click launch. And it will ask you for a key pair. Create a new key pair and give it a good name. Here we're going to choose Hadoop Cluster Key. Then click on Download Key Pair. Save it in a safe place. And make sure you don't lose it. Then go ahead and click Launch Instances. Those will start to create in the background. You will then be able to connect your instances in a later video in the series. So to summarize, we talked about choosing the right AMI and having all of the right settings. 3 servers, large, CentOS, and we are using HTTP version 2.0. Coming up in the next video, we will be talking about setting up elastic IP addresses for those servers. Also on how to shut down or start up those different cloud instances. Hello and welcome to Building Hadoop Clusters. This is Section 1, Video 3, Deploying Cloud Instances for Hadoop. In the previous video, we learned how to choose an Amazon machine image and how to deploy the AMI with the correct settings. In this video, we will talk about setting up elastic IP addresses and shutting down, suspending, and starting up cloud instances. First, let's navigate to the AWS website. Here you go to the Management Console, then the AWS Management Console specifically. From here, navigate to the EC2 dashboard. Again, we come to the EC2 dashboard screen with the set of options. Right now, you will notice we have 3 running instances from the previous video. If you click on the running instances link, you will see that 3 that we have. If we go back to the EC2 dashboard, we can check and see we have 0 elastic IP or more addresses. Here we see we have 5 elastic IP addresses assigned. So let's go ahead and create some elastic IP addresses for our instances. Click on Elastic IPs to go to the Elastic IP screen. Click on the Allocate New Address button. Then select to use the EC2 Elastic IP address. Click Yes Allocate, and you'll see that one is created. We have 3 instances, and so we want to create 3 of these. So you can go ahead and allocate again, and if you only have 2, allocate one more time so you have a total of 3. Then for each one, we can associate an elastic IP with one of our instances. Click on the Associate button. After you select one of these, and that's the associate address, then select the first instance to be associated with the first elastic IP address. And from there, you can do your association. We will see the public DNS address is typically server can change. When we use elastic IP address, it now becomes dedicated to that instance. If you go back and click on instances for your 3 running servers in the EC2 dashboard, you can see where that public DNS is. And if we assign an elastic IP to one of these, you'll see the public DNS changes to the elastic IP address. Now keep in mind, Amazon does have a limit on the number of elastic IPs that you can assign at any time. When we are in the instance screen, we have the options for each of our instances where we can modify them. If you select one of the instances, you can see action buttons come up. You can select what are the different actions you have for this particular instance. Depending on the AMI that you choose, you have different options. Here with the AMI that we have chosen, we only have the option to terminate or reboot this instance. So let's go ahead and terminate all 3 instances and see how that works. Here I've selected the 3 instances. I'm going to go ahead and say yes, terminate these. And from there, you'll see after you click yes, terminate, those will go into the shutting down mode. And this gives you an idea how to operationalize some of the different instances in your Hadoop cluster. So to summarize, we talked about creating elastic IP addresses, how to dedicate a defined IP address for each instance. Also, we discussed the EC2 dashboard and some of the options. If you want to shut down and turn off one of the AMI images, it depends on the one that you have and the options available. If you do a suspend, it will allow your image to stay in a suspended mode and allow you to turn on that Amazon machine image at a later time. We also showed you how to completely terminate one of those instances, and we showed you how to navigate the overall EC2 dashboard to do that. Coming up in the next section, we will go over section number 2, where we will talk about setting up your network and security settings for your EC2 instance for Amazon, getting them prepared for the Hadoop installation. Hello, and welcome to Building Hadoop Clusters. This is section 2, Setup, Network, and Security Settings. In the previous section, we covered multiple topics. we gave an introduction to the Amazon cloud, and we talked about AWS and using it for deploying EC2 instances, as well as how to deploy the right Linux Amazon machine image. We also set up elastic IP addresses and showed you how to start and terminate instances. In this section, section number 2, we will cover network and security settings. Specifically in this video, we're going to take an overview of security and network connectivity to the Amazon cloud. This includes creating security groups to help identify the correct inbound and outbound IP addresses and ports. We will also assign EC2 instances to security groups so they take on these network settings. Finally, we will show you how to use private keys in a Windows client environment to connect to your instances. There are 2 methods for connecting to each of the Amazon instances. The first method is using the Amazon web client that you can access through the EC2 dashboard. This is known as a thin client because you do not have to download any software. The other method for connecting to your instances is you can download a client and run it off your computer. This method is known as a thick client. In this video series, we will be downloading a free tool called PuTTY, which uses the SSH protocol to connect to instances in the Amazon cloud. The second goal for this video is around security groups. Security groups implement the concept of Amazon firewall settings. For your instances, you're going to define a security group. You can assign that instance to a security group and it will define the firewall settings allowing IP addresses that can connect to the instances and through what ports. The format's going to be in the form of IP address /number, and the X's represent the IP address that are the acceptable IP addresses in the security group, as well as the Y's that signify the open ports for communication. For Hadoop services in your cluster, we are going to be using multiple jobs or processes that are running on different ports in the cluster, and so we have to account for those. If you decide to go with the security setting that locks down the environment Amazon cloud, then we will have to account for these different IP addresses and ports that will be used in Hadoop. We will show you how to do that now as an example. However, setting up a complete security group for Hadoop is outside of the scope of this course. We will show you how to make some simple security group settings that all ports are open, but only for a defined set of IP addresses, namely your client and the Hadoop nodes in the cluster. If you navigate your web browser to Hortonworks website, you can look at the documentation for the Hadoop distribution below the Hortonworks stated platform. We showed you this in section 1, video 1. We click here on HDP, which takes us to the HDP home site, where then we can click on documentation. Click on documentation and installation manual, and you will be able to go down to deploying, configuring, and upgrading Ambari, which you see here. Ambari is basically the management software for Hadoop. Now, if we expand under this tab, you can see an area called Configuring Ports. In that section, we will see all the different services that are within Hadoop, and for example, if you click HDFS ports for the Hadoop distributed file system, you will get an idea of all the ports that you'll need to have access through if you decide to lock down your cluster. Keep in mind, if you define to secure ports in Amazon security groups, make sure you account for TCP and UDP protocols. Now that you've seen all of the ports required to start your Hadoop cluster, we will use this list as an example in the next section to create a security group so that you know how to only use the ports needed for Hadoop. Now go to the Amazon website, AWS Management Console, and log in. Go ahead to the EC2 dashboard and you'll see here is where you can define your security groups. See the section called Security Groups, and if you go ahead and click that, you can see where you can actually define your security group settings or existing settings. We will talk about how to use the security groups in the next section. So to summarize, in this section we have learned about the Amazon connection methods for the AWS instances, and we also talked about security groups and what ports you need to define for a Hadoop cluster. Coming up in the next section, we'll be identifying and allocating security groups and giving an example of how to set them up. We will then assign the security groups to the instances. Hello, and welcome to Building Hadoop Clusters. This is section 2, Setup, Network, and Security Settings. In the previous video, we talked about security groups and network connectivity in Amazon Cloud or AWS. We also went to the Hortonworks website to identify the documentation where we want to lock down network security settings for the Hadoop cluster. We identified the process and ports on which these services run. In this section, this video is going to be talking about identifying and allocating security groups. We will create a security group, and then we will also define security settings such as which ports are open and which IP addresses are allowed. We will also assign our EC2 instances to this security group. So let's get started. Take your web browser and navigate to the AWS website, and you're going to go to My Account Console and log in. You'll go to the AWS dashboard where you can click on the EC2 dashboard where we are currently. Here you'll have to see multiple options, but we specifically want to go to security group, and you'll notice the security group that was created in the last section when we created our instances. Go ahead and find the security group you created when we launched our instances and click the checkbox next to it. Once your security group is checked, go down to the bottom of the screen and you'll see you'll have details about your security group. Now click on the Inbound tab. The Inbound tab will allow you to define security group settings for this particular security group. We don't have anything defined, so go ahead and click on the combo box here that says Create a New Rule. And after the drop-down occurs, you'll see all the different protocols where you can define or create a security group setting. First, let's create a rule for SSH, which is the protocol that allows us to connect to our instances. Click SSH from the menu, and then add the rule. Here you will see new rules added to your IP and port, and allows inbound connections for port 22, or SSH. Next, since we are building the Hadoop cluster, we'll need to add custom rules for each of the Hadoop services if we want to secure the network. So let's just show an example of a custom port rule. Go ahead and click Custom TCP Rule. And once you do, you'll see that the source IP address, which are zeros separated by a period, and also a / or 0, which is the port. Keep those as is. This means that you can basically apply the rule to any source IP address and port for incoming source connections. However, later on, if you want to create a secure network, you'll want to determine the IP addresses of all the nodes in your cluster, as well as any clients that will connect, and add them to this list. Additionally, you are asked to define a port range. Here you can put in a single port or a range of values of ports that your server will accept requests on. Let's go ahead and find the ports you need to add for Hadoop services from the Hadoop documentation, and then we'll add one. We see here first the HDFS port we need is 570. Put that in and then click Add. See here we clicked anywhere so that we have all the zeros for the IP address that can be any source and any port. If you decide to secure the network, make sure you continue creating rules to open all necessary ports for Hadoop. We won't show you adding all the rules in this video. However, here is what your final list could look like. When we looked at all of the ports that needed to be open for the Hadoop system, we counted to 38 in total, but that may change. You will also need to determine if you are using TCP or ADP. Additionally, Hadoop ports can change from version to version, so if you are having issues deploying, remove the network's security and add it in at a later time. Finally, for the scope of this video course, we want to make sure that you will be able to deploy the Hadoop cluster correctly, so we're going to create a blanket network rule that keeps all ports open. Go to the combo box and add the All TCP rule, and then click Add Rule and save settings. Extra TCP rule in the system, we're going to go ahead and X that out. And now we have our All TCP rule. We'll go ahead and save that. And now that we've defined security group, we'll go over and click instances, and we'll see different nodes that are running in our instances. These are each of the Linux instances we created, and now we can click on one of these instances and you can see its security group defined. Now these instances that we have here were created at a later time, and we see that for the current system, we have our security groups towards the end here, and these are in the default security group. Now, depending on the instance that you've defined, you may have the option to come in and change the security group for that instance if it's supported. And if so, you can go ahead and change the security group details. As we've said before, you can always terminate, recreate instances, and you can change the security group settings you have tied to a particular instance. So to summarize, we taught you how to identify and allocate security groups. We showed the different rules for the security groups, and specifically the ones we need for Hadoop. In the next video, we will talk about the downloading and configuration of private keys in the Windows environment, and we'll also look at utilizing the PuTTY utility to convert those keys into a format that we can use with the PuTTY tool to connect our instances. Hello, and welcome to Building Hadoop Clusters. This is Section 2, Setup, Network, and Security Settings. In the previous video, we talked about identifying and allocating security groups and how to set the rules for different TCP ports and the security groups for Hadoop services. In this video, video number 3, we will talk about downloading and configuring private keys for the Amazon cloud in a Windows environment. We will also talk about utilizing the PuTTY utility for converting keys to a format you can use with the PuTTY terminal utility to connect to your Amazon instances. Security is very important in a cloud setting because our Amazon EC2 instances are running on the public internet. If we do not define a strict level of access and make sure we configure our network settings properly, someone may be able to hack into our machines, and we certainly would not want that to happen. Let's get started, and if you go to aws.amazon website and log in with your username and password, going to the EC2 dashboard, you'll notice that you have a section for key pairs and running instances. In this case of our running instances, you'll see the key name is defined as Hadoop cluster key. We defined this key in Section 1, Video 2. The wizard asked us to create a key pair. We then created this key pair and we downloaded it to our computer. Now you may have downloaded it to your computer or you may have lost it. This happened to me as well, but don't worry, recreate these instances with a new key pair. Let's see how that works. You will see that we have a key pair here defined under key pairs in the EC2 dashboard. And if we select key pairs, we see that we don't have a way to download these key pairs. Essentially, what a key pair is a file you download to your computer, and then it allows you to use that file as your login credential into Amazon instances. We see we can't re-download this, and if we've lost the key pair, we cannot connect to these instances. So what we're essentially going to do here is delete these instances and go ahead and terminate them through the action button. We're going to go ahead and keep the AMI machine image to use later. And then we're going to look at the action button and click terminate. You can quickly recreate these instances as we did last time using the same AMI information that we used from the previous section in our recommendation from Section 1, Video 2, or as I copied it here. Once you identify that image as a larger instance, you'll go ahead and create 3. So let's do that quickly by clicking on Launch Instance, going to Community AMIs. I'll use the AMI number that I copied and pasted. Click Select. Choose 3 large instances, and we'll select 3 here. As we did previously, add storage, tag instance. We'll keep going. Here we'll use an existing security group. It's the Hadoop security group. Click Review and Launch, and then go ahead and launch. And you see here, it's asking us for a key pair. Now we actually want to create a new key pair. We're going to give this a Hadoop cluster key number 2. And then we will download that key pair. Here we can download it to the desktop, and we'll do that, the PEM file. And that's it, we're done. Now to use a key pair we just downloaded, we need to first download the PuTTY utility. So let's go into Google, and we'll search for PuTTY SSH. This brings us to the PuTTY download page. We see that's right here. We see the PuTTY utility for Windows, and we want to go ahead and save that file. Go ahead and do it to the desktop again. If you go to your desktop and then run the PuTTY utility, go ahead to Conversions and import key. select the Hadoop key that we just found, which is Hadoop cluster key 2, and then click the Save Private Key button. We want to save it without a passphrase, that's okay, and then we'll give it a different name than our PEM file. Call that Hadoop Windows key. And now you'll see it saved it as a PPK file, actually. We're all set. We can go ahead and close PuttyGen, and you should be able to now create your own private key file, download it, and convert it to a PPK. And use that to connect to your Amazon instance. So we'll be using these two later that we just created. You won't need PuttyGen anymore, but you can keep that for later use. And so to summarize, we taught you how to download and configure private keys. Please remember that your keys are not replaceable. If you lose a key, then you'll need to recreate a key, and that may cause you to have to recreate some of your instances. So it may be a good idea to back up your key. Coming up, next we're going to have section 3, and we'll be teaching you about connecting to cloud instances through Windows. Hello, and welcome to Building Hadoop Clusters. This is section 3, connecting to cloud instances through Windows. In the previous section, we covered the following topics. We talked about the Amazon cloud around security groups, how to set up security groups, and we also talked about how to define the different inbound and outbound IP addresses, as well as port specifications, specifically for the Hadoop instance. We also identified and showed you how to create a security group and assign the security group to an instance. We also showed you how to use the PuTTY utilities to convert a private key for connectivity to cloud instances. In this section, we will talk about the Amazon Thin Client for connections, followed by setting up the PuTTY tool. We will use PuTTY to set up saved configurations for Amazon instances so that we can connect automatically. Then we will finally look at transferring files over to our Amazon instance. So specifically in this video, we will give you an overview of the different options you have for connecting to your instances in the Amazon cloud. In this video, we will talk about one of the easier options in Amazon that has less flexibility but is very easy to use, and that's Amazon Thin Client for connections. When we talk about connectivity options, there are a few options for connecting to your cloud instance. In either scenario, you will use the SSH protocol. The first option you can use is the Amazon Web Client, and in this video we will show you how to use the web client. From the EC2 instance dashboard, you will use a Java web program that will allow you to connect to your instances. The other option is you can also use a client terminal that installs some software on your computer. It's a free software called PuTTY, and to download it to your computer, just go to the Google and type in PuTTY SSH. The first link that comes up is a link to the PuTTY utility. Remember, in both scenarios, you're using the SSH protocol, and SSH protocol uses port 22. So whatever security group you assign to your instance, make sure that security group account or port number 22 is open. So let's get started. We will look at connecting to the Amazon instance using the Thin Client for connecting to one or more instances. Type aws.amazon.com in your web browser. Go to My Account and AWS Management Console. Log in with your username and password, and next you're going to go to the EC2 dashboard, which we already have open here. Once you're here, you're going to click on Running Instances, and if you followed the steps in the previous video, you should have 3 running instances. We gave you recommended AMI in the previous video, and we also defined a key name pair for login. We also showed you in the previous video that if you lose your private key file, you can always recreate your cluster instances. However, deleting and recreating instances is time consuming, so let's try and avoid that. So to connect, pretend that we wanted to quickly access the first instance here, and so we click the checkbox next to the single instance, and you see that the button gets highlighted that says Connect. Once you click the Connect button, you will see that you have 2 options for connecting your instances. The standalone client will give you your public DNS address you can connect to, but if you click on the Java SSH client, we see here a username, and you can use a root, and then we have the private key we downloaded, the PEM file. This is before the PuttyGen conversion. I'm going to copy and paste the directory I placed my private key file in for the name, and add the .pem. This was the Hadoop cluster key 2 file that we created. When this is complete, we click Launch SSH Client. The program will proceed the process of launching the SSH client through Java. It does take some time to spin up, and the Java program will install any software you need on your computer, unless you already have Java installed. Next, you'll see here we have an SSH client through a window pop up. We log in through the window automatically, and if we type "Who am I?", which is a command that tells what user you're logged in is, it'll tell us that we're root. We see thin client user access is one of the methods of connecting to your Amazon instance, albeit slow. So to summarize, we gave you an overview of the connectivity options you have for connecting to Amazon Cloud instances through Windows. We showed you the Amazon Thin client for connections. Coming up, we're going to be talking about the preferred method, which is installing and using PuTTY. PuTTY is your native tool for connecting to Amazon Cloud instances. We will install PuTTY on your client workstation, and we'll show you how to configure PuTTY for saved sessions so you can continue logging onto your instances using PuTTY on a daily basis. Hello, and welcome to Building Hadoop Clusters. This is Section 3, Connecting to Cloud Instances through Windows. In the previous video, we gave a beginning overview of the connectivity options for Windows connecting to the Amazon Cloud. We talked about the Amazon Thin client, which you can access through aws.amazon.com. In EC2, you click the Connect button for one of your instances, and then you'll have your web browser basically make a terminal for you using a Java Thin client. In this section, we're going to be talking about installing and using PuTTY for connectivity as the Windows client, which is our preferred method for connecting to Amazon instances. We will also show you how to configure PuTTY for saved sessions. So before we get started, make sure you have PuTTY installed on your client system. You can download PuTTY directly from the web. To download PuTTY, just go to Google and type in PuTTY SSH to go to the PuTTY homepage for download. Further in this video, we recommend to please make sure to keep port 22 open in all of your security groups, along with any Hadoop processes ports open if you choose to have security in your system. Let's start off by going to Google and typing PuTTY SSH so we can get PuTTY exe from the website. See, that's the first link that comes up, and we go ahead and click on it, and then we see here we're at the PuTTY homepage, which is the free Telnet SSH client. We want to click the download link, and here we have a list of tools. You'll remember from the previous video, we downloaded the PuTTygen utility that allowed us to take our private key and convert it from the .pem file to the .ppk extension. In this video, we use the .ppk file, but first we have to download the PuTTY terminal. That's the first link here. So go ahead and click the PuTTy exe link and download the file. Find the PuTTy exe downloaded, and we're going to go ahead and run PuTTy. The PuTTy configuration screen comes up first and needs a hostname or IP address for the instance. So let's go to aws.amazon.com, log into your account, and go to the EC2 dashboard so that we can see the running instances. We will see here we can click on one of these instances, and as soon as you do, you can see the details of that instance and the public DNS in the lower right-hand corner. Make a copy and then go back to the PuTTy configuration window, and here in the hostname, paste the DNS address for the instance. Call this the Hadoop name node. We will discuss what this means in Hadoop terms later. However, for now, just know that Hadoop name node is synonymous with the head or master node. You will hear it referred to in this video as one of those three terms interchangeably. Some other changes you're going to need to make to PuTTy are in the connection settings. On the left-hand side, you will see a hierarchy titled Connection. Expand on Connection and then click Data. Here you will see a section for auto login where it asks you for the username. Please type in root. Next, to define the method of access, we need to go to SSH, expand under Authentication, and it says private key file for the application. So click Browse. Find the private key that we created previously. This is going to be the Hadoop Windows key that we created in the previous video. We're going to select that, and then we're all set. So go back to Session at the top, and then just click on Save. This will save the Hadoop name node instance, and then next when you click on Open in the lower right hand corner of PuTTY, you will see here they ask you for a security alert. Just say yes. As this is an unrecognized host that we don't trust, we want to make sure that we trust it, and so it asks you to log in. Once we're logged in, we type who am I, and we see that we're logged in as root through the PuTTY session. So to summarize, we learned how to install PuTTY and download the client. We learned how to save the session and connect to it so that we have the root name and the .ppk file all ready to go with the config save session. Coming up, we'll be talking about how we can transfer files to over Linux and doing it to our Amazon EC2 instances using the PSCP tool. Hello and welcome to Building Hadoop Clusters. This is section 3, Connecting to Cloud Instances through Windows. In the previous video, we showed you how to install PuTTY and use it as a tool to connect to your Amazon instances. We also showed you how to gather the information needed to connect those instances and save PuTTY configuration settings. Once the PuTTY configuration settings are saved, you are now able to log into your Amazon instances with a click of a button. In this section, we will cover transferring files to Amazon Linux instances by using the PSCP tool. For our purposes, we are going to need to send files over from our client machine to the Amazon instances. In our case, we use the PSCP tool, which stands for PuTTY Secure Copy. It allows you to take files from your client workstation and transfer those files over to your Amazon instance. We do that by downloading the PSCP from the PuTTY website, just like we did in the previous video series. To get started, open your web browser and go to Google. In the Google search box, type in PuTTY SSH. This takes you to the PuTTY website, and then from here go to the download section and click on the PSCP exe. Download that file. Here we download it to the desktop, and from there we're going to go to the Windows Explorer. We want to open a command prompt with a path to the desktop, so in the address bar, we type in cmd. Next we type the PSCP command, the -i option, and then we have to define the private key file to use as we have with the .ppk. See that auto completes. Next in the command line we define what file we want to transfer over with PSCP. In our case we want to transfer over the private key file, the .pem. And we want to transfer the private key file because it will allow us to log in from one instance to another without credentials. So remember this one was number 2. We'll put that in. Next we add the username, which is root, followed by the @ symbol. And then we get the public DNS address for the Amazon instance. So go to the EC2 dashboard. Click on your instance we defined as the head node previously and copy the public DNS address. Then go ahead and paste it into the window, followed by a colon symbol, and then the path where we want the file to go. In our case, we are going to be sending it to the hidden .ssh folder in the root directory. That's the user root .ssh folder. And we want to rename the client file to ID RSA, which is what we call the private key file in the Linux operating system. Next, we proceed to click enter in the DOS command window. It will ask you to recognize the hostname. See here, there was already part of the hostname, so automatically transferred it. We can check that through PuTTY. If we use the original Hadoop name node instance we saved in the previous session and click open. So here we load PuTTY. See we have the Hadoop name node and click open. And we're logged back into that instance. If we go to the root directory, followed by the hidden.ssh folder, and then we type in ls to list everything in this directory, we see that we have the ID RSA file. So if you need to look at the command syntax again, we have it pasted here, giving you the options on how to use each one. So to summarize, we learned how to transfer files using the PSCP tool. We transferred the original private key file to our Amazon instance. We then put the file into the root directory so we could easily log into the instance from any instance. Coming up in the next section will be section 4. In section 4, we will talk about network connectivity and access mechanisms between nodes in the cluster. Hello, and welcome to Building Hadoop Clusters. This is section 4, setting up network connectivity and access for Hadoop clusters. In the previous section, we covered an overview of connectivity options for Windows to the Amazon cloud. We saw that through the EC2 dashboard, we can use the Amazon Thin client, and through our web browser have a terminal where we can connect to our Amazon instances. We also saw that you can also download a utility to your Windows machine which is free, a client utility called PuTTY. We configured PuTTY so that we can automatically connect to the name node or the master node in the Hadoop cluster. We used the configuration information and we created a saved session in PuTTY so that we can automatically log in with one click. We also used the PSCP tool to send our private key file to the Amazon instance head node. In this section, we are going to take a look at defining the Hadoop 2.0 cluster and what that looks like. We'll talk about how we can set up passwordless SSH on the head node, which will allow us to use the head node to log into any of the other nodes in our cluster. We refer to the head node here as a node or gateway host in our cluster that we are interacting with. In addition, the head node is eventually going to be our name node in the Hadoop environment once we install the Hadoop software. In this video, we are going to be gathering network information for each of the nodes in the cluster. We then use that network information to set up the host file on each of the nodes for our 3 nodes in the Amazon cloud. Finally, we'll make sure we validate the network and make sure everything lines up and is correct for the Hadoop 2.0 cluster installation. Once this is confirmed, we can continue setting up the system in section 5. In this video specifically, we are going to be looking at further defining the Hadoop cluster. We want to make sure that everyone watching this video understands how the Hadoop cluster works, and for each of the components, we want you to have an understanding of the difference between the name node and the data nodes. You will also hear these two types referred to as master and slave nodes, respectively. So before we move forward, we want to make sure that everyone's on the same page. So let's do a status check. I believe you are ready to continue with section 4, but let's confirm that you've done the following 5 things. Number 1, we want to make sure that you've created 3 large Amazon EC2 instances. You should be running CentOS Linux 6 version. You can find out how to create an Amazon instance running CentOS in section 1 of the series. Number 2, we want to make sure that you have a security group set up correctly for Amazon instances. All the TCP ports should be open that we discovered in the Hornworks documentation, as well as port 22 for SSH and port 80 for HTTP. You can make sure you have the correct security group settings by reviewing section 2 of this course. Number 3, we want to make sure that you have the private key file, both the .pem and the .ppk. We use the PuTTYgen utility to convert the .pem file to the .ppk file. You can learn how to do this in section number 2. Number 4, make sure your PuTTY client is set up properly with saved configuration settings. You want to make sure that we have the PuTTY client set up to connect to all of our instances in the cluster. You can find out how to do this in section 3. Number 5, finally, we want to make sure you have uploaded the .pem file to the head node in your cluster. You can use the PSCP tool to transfer the .pem file to the node in your cluster. And we taught you how to do that in section 3. Now let's discuss the architecture of the Hadoop cluster. We will not talk about Hadoop 1.0 versus Hadoop 2.0 cluster in our video series. Instead, we are going to be teaching you how to install the Hadoop 2.0 framework for your clusters. However, do not worry, as there is a lot of similarities between the two. When we talk about the general architecture of the Hadoop cluster, what you will see is that you have 2 different types of logical servers. In our cluster for this video series, we have 3 Amazon instances. At the top, we have the master, referred to the head node, or also the name node. The name node is the master instance that runs the HBase master, as well as the resource manager in Hadoop 2.0. The name node is used to store metadata about objects and coordinate services across Hadoop. The other two instances in our cluster are the data node 1 and data node 2. The data nodes are the slave instances within the Hadoop cluster. The data nodes are where the data resides and actual computation occurs. The data nodes are running the HBase region server, node manager, as well as other services we will cover in a later section. In the Hadoop 1.0 architecture, the main difference you are going to see is that the job tracker in Hadoop 1.0 is now the resource manager. The resource manager lives on the name node. We also see the task tracker in Hadoop 1.0 is now the node manager. The node manager lives on each of the data nodes in your Hadoop environment. We won't go into specifics about each of these components. However, suffice to say that one of the key changes for Hadoop 2.0 is a technology called Yarn, yet another resource which allows for a decoupling of resource management and job schedule monitoring, which are combined in Yarn's predecessor, MapReduce 1. We defined the Hadoop 2.0 architecture and how it works. We made sure that we have a status check and that everyone's on the same page with the proper configuration settings to start getting set up for install Hadoop 2.0. As we move forward, delivering the build out of the Hadoop cluster in section 4, we will slowly prepare ourselves for the installation. Coming up in the next video, we will be talking about how to set up passwordless SSH on your head node. Hello and welcome to Building Hadoop Clusters. This is section 4, setting up network connectivity and access for Hadoop clusters. In the previous section, we covered an overview of the Hadoop 2.0 architecture. In general, we discussed the makeup of our Amazon cluster. Our Amazon Hadoop cluster consists of 3 large Amazon instances running CentOS. We also discussed the type of nodes we have in our cluster, such as the head node, which we are interacting with as a gateway, and will eventually become the name node in our Hadoop cluster. The head node is also referred to as the master. As well, we have the slave nodes, which refer to our data nodes. We saw in the previous section the differences between the architecture in Hadoop 1.0 and Hadoop 2.0. Namely, the fact that instead of the job tracker and task tracker, we now have the resource manager and node manager respectively. In addition, we also covered a status check for our viewers in the previous section. This status check covered 5 key areas we need to set up before we get started in this video. If you were not able to verify your status, please go back to the previous video to confirm. In this section, we are going to take a look at how we can configure the nodes in our cluster to have passwordless SSH. What passwordless SSH essentially means is we will be able to SSH log into any of the instances in our cluster from any other instance without having to define login credentials. In short, internode communication within the cluster. The first step to doing this is defining the private key file for our root user. If you remember in our previous section, section 3, we showed you how to use the PSCP tool. In particular, we used PSCP to upload our private key file on our client machine to the /root/.ssh folder with ID_RSA as the name of our new private key file. So let's get started on setting up our cluster for passwordless SSH. Our first step requires us to load up PuTTY to the client. You should have already have your configuration settings saved for the name node from our previous section. Go ahead and log into the name node as root so you are at the command prompt. Next, you are going to want to navigate to your root users.ssh directory. You can do this by executing the following command: cd/root/.ssh. Once in this directory, we have to make sure that we set up each of our .ssh files with the correct permissions. To set up permissions for each file, we will use the chmod command, which stands for Change File Modes, or Access Control Lists. When using the chmod program, you will define a file for chmod to run on, as well as permission levels for 3 groups: owner, group, all others. You can define a file's owner and group using chown command. The format for chmod comes in 3 numerical digits, with the first digit referencing the owner, second the group, and third all others. The higher the number is, between 0 and 7, the higher level of access each owner, group, or other has respectively. We will want to execute the following commands: chmod 700 root.ssh. chmod 640 root.ssh authorized keys. chmod 600 root SSH ID RSA. In terms of permission levels, the numbers mean the following. 7 equals read, write, execute. 6 equals read, write. 4 equals read. And 0 equals no access. Once we have set up all the necessary permissions for our files and have uploaded our private key to the proper directory, we are ready for passwordless SSH. Next, let's log into the EC2 dashboard and get the public DNS address for one of our slave data nodes. Once you have the public DNS address, which we get by copying here, you can type the following into the PuTTY SSH terminal window. SSH, and we paste what we just copied in terms of the DNS address. SSH is currently configured to do strict host key checking, which means if it finds a host you're trying to connect to for the first time, it will ask you if the host is safe. Type no so we can try this again. To make things more convenient, we are going to want to turn this feature off. The strict host key checking feature is a configuration setting in the SSH configuration file located in the /root/.ssh folder. Since we haven't created one, we will just create one using vi with the following command. vi/root.ssh / the name of the file, which is config. In this text file, you will want to add the following line that says strict host key checking equals no. So we'll press I to go into insert mode. Type in strict host key checking equals no. This key value pair is case sensitive, so make sure you type it in properly, and then press escape to exit insert mode, and then save the file by holding down the shift key and pressing the Z letter twice, so it's a capital Z. You can do this with whichever Linux text editor you prefer, if you do not prefer VI. I personally prefer VI, and you can use VI by just typing in the VI command followed by the path and file name. Correspondingly, a much slicker and easier way to create the configuration setting is to use the echo command. First, let's delete the file we just created with the remove command, or rm. So we'll type in rm config. Here we'll say yes. And now we'll see a series of commands that we've pasted here. We can use the echo command displayed here to create the config file and place the string where we need it. So here I'll copy this echo command and go ahead and paste it back into the window. And we see here that it has properly made the config file. The command displayed here will echo the string in quotes and create the configuration file for SSH. Finally, we need to restart the SSH daemon service so that the new configuration settings will take effect. You can do this by typing in service sshd restart. And once this is completed, let's make sure SSH works properly now by typing in the following command one more time. SSH and the public DNS address that we had. And it looks like copying and pasting from PowerPoint wasn't good. So let's just go ahead and do this one more time. And we see that work. So now it doesn't ask us if we actually need to know the host. We've already turned strict key host checking off. You should now log in directly to one of your slave data nodes without a need for a password when you put this configuration setting in place. And once this is complete, you want to type exit from here so that you log out of that node that you just logged into and you go back to the name node or master. In this section, we learned how to set up the head node to utilize passwordless SSH. We started by making sure we had our private key file in the right place, followed by the right permission setup. Next, we learned how to change the SSH configuration file so that we do not need to do strict host key checking. In the next video for this section, we will learn how to gather all the information we need from a networking perspective. We will then get the network address information for each node in our cluster and configure the host file. Hello, and welcome to Building Hadoop Clusters. This is section 4, setting up network connectivity and access for Hadoop clusters. In the previous section, we covered setting up your head node, name node, for passwordless SSH. We first started with making sure we uploaded our .pem file to the Amazon instance using PSCP. We also renamed our .pem file to id_RSA. Next, we had to set up the correct permission settings for each of the files in our .ssh directory. Once the proper permissions were set up, we next went on to setting up the SSH configuration file. Specifically, we set up the SSH configuration file to disable the strict host key checking feature so that we could easily jump onto any node in our instance. Finally, we restarted the SSH daemon and made sure our SSH was working. In this section, we are going to take a look at gathering the network information necessary to set up the network details on each of the nodes in our cluster. We will see that though we have a public DNS address, there is also an internal FQDN address for each of the nodes in our cluster. FQDN stands for Fully Qualified Domain Name, and gives both a proper host name and a domain for each of the nodes in our cluster. FQDN is important because it gives the explicit host name and domain name of your node so that there is no misinterpretation. Once we have this information, we will set up the host file on each node. There are a couple of key elements we will need when gathering the network details for each of the instances or hosts in our cluster. The first thing we need to do is utilize the hostname command in Linux to get the information we need. The information we will need to gather is the IP address for each node in our cluster, as well as the FQDN for each node in our cluster. The FQDN comes in the following format: the hostname, period, domain example, period, .com. The first term, the hostname, is a local hostname for the machine, followed by the parent domain, which in this case is domainexample.com. To get both the IP address and the FQDN for each of the nodes in our cluster, we will execute the following commands shown here: hostname -i, or the I option, and hostname -f, or the F option. In this case, the -i option gives us the IP address of this node in the cluster, and the -f command gives us the FQDN. Now that we know how to get both the IP address and FQDN for each of the instances in Amazon, let's take a look at the host file. The host file on any Linux machine is a configuration file the Linux operating system uses to resolve host names to IP addresses. We can manually edit the host file so that we can explicitly map an IP address to a host machine's name. The host file is located in the /etc directory under hosts, all lowercase. The general format for the host file starts off with the IP addresses, then one or more host names, all tab delimited. So let's take an example. Here in our example host file, we see the following line: 127.0.0.1, localhost, and loopback. This is a line you'll typically see in the host file. What this line is telling us is that the host name, localhost, actually resolves to the IP address 127.0.0.1. which is the IP address of our own node. This is also known as a loopback host, and so if a network host name is referred to as either localhost or loopback, either will resolve to 127.0.0.1. You will also see some lines that start with the ##. When this occurs, these lines are known as comments, and the OS effectively skips these lines when reading the host file. Now we are going to work on setting up the host file on each of the nodes in our cluster. If you remember from the last video, in this section we taught you how to set up passwordless SSH. Thus you should be easily able to log into any of the nodes in your Amazon cluster from the name node or head node. All you need to do is execute the SSH command at the Linux terminal prompt when logged in from the head node. Next, let's gather the network information we need for each node and send to the host file. Here you'll see I've created the following command that you can utilize that will quickly get you both the IP address and the FQDN of the node that you execute the command on. And if we go ahead and log in, here we have our head node that we're logged into. First, we're going to execute this command. And see, we have the IP address, the FQDN, and what we're using for the head node alias, H1 here. So we're going to copy that. Now if we log into the first data node, and we get the public DNS from here, here we see we're logged in, and here we use the echo command to echo the line of text again. Now more explicitly, what you're seeing here is that the lines echoing are actually Linux shell commands. When we wrap a backtick around the statement within echo, it will actually execute the statement and place the results of the command in its place. So when we say echo with the hostname -i in the backticks, the hostname command will actually resolve to the IP address of the node we execute the statement on. Here you see we've included the hostname -i and the hostname -f so that we're getting both of them. And we've also included the \t, which resolves to the tab character. Finally, we have named the head node alias h1. And for the data node 1 and data node 2 respectively, we're going to name those n1. And here we have the information about n1, saving in the notepad file. And we're going to run this command on data node 1, which we just have in data node 2. Type exit to go back to the head node. And then we want to SSH into data node 2, so we'll get its public DNS here. Here we see we're logged in. We'll use our same echo command, naming this n2. Copy the information for data node 2. And then, once again, go back to the terminal and type exit to go to the head node. Now that you have the notepad file with all the necessary information you need, type in the following to open the host file on the head node. vi/etc/hosts. We go down, we put the system into insert mode, pressing the I button, and then past this line, we're going to want to copy and paste all this information that we just saved in the notepad. We do that, press escape to leave insert mode, hold down shift and press Z twice for capital Z, that saves and exits VI. And then we're going to do this one more time by SSHing into each one of our data nodes and making sure that they have the correct host file information as well. There's data node 1, exit, and then SSH into data node 2. Edit the host file. Save that and exit. So to summarize, in this section we learn how to gather the network information for each of the nodes in our cluster. We also learned about the host file and how to properly set up the host file in the correct format. In the next section, we will learn how to set up the remaining configuration settings on the nodes in our cluster so that we are thoroughly prepared for our Hadoop installation. Hello and welcome to Building Hadoop Clusters. This is Section 5, Setting up Configuration Settings Across Hadoop Clusters. In the previous section, we covered multiple areas giving you a background on Hadoop 2.0. We first started with defining the Hadoop architecture, connecting through and setting up SSH, and providing network information. We also provided a status check to make sure you are prepared for the next sections in this course. In particular, up to this point, you should have already set up 3 Linux instances on Amazon EC2 and should already be familiar with connecting to each instance through Windows and submitting commands. If you are not, please refer to sections 3 and 4. In this section, we are going to take a look at the remaining key components needed in terms of setup before we start the Hadoop software installation. We are going to have to make sure that the Linux software repositories we have set up are correct and up to date. Next, we will set up the PDSH tool, which will allow us to issue one command that takes effect across all of the nodes in our cluster. Then finally, we will work to make the appropriate configuration changes in the Linux operating system such that we have the correct run levels, file permissions, and enabled, disabled, and necessary processes. Specifically for this video, we will focus on setting up the Linux software repositories. So let's get started. When we talk about installing software on the Linux operating system, we have multiple options. We want to make sure we take the right steps to prepare the software installation process and everything goes smoothly. One of the options is to get the source code and compile the code using the make utility. Another option is to download executable or batch programs compiled for our particular Linux distribution. Finally, we can rely on third-party software that is made specifically for installation on Linux. These Linux installation tools use software repositories or repos that are online libraries that store the Linux programs for each system. In our case, since we are using a CentOS distribution, or a Red Hat derivative if you will, we are going to utilize the yum utility, which will make our lives much easier, as long as we have the software repositories on our machine set up correctly. The key piece of information you should be aware of is that software repositories are defined by files that end in .repo or .repo. We need to store any of our .repo files that point to online software repositories in the /etc/yum.repos.d as in dog directory. They also need to be up to date. If you haven't already, please make sure you are connected to the head node through the PuTTY terminal. We will proceed to check the current files in the yum repo directories by issuing the ls command in the etc yum.repos directory. You will see the standard CentOS repos like base, etc. Since we need to download and install the Hadoop software and also some tools like pdsh, we will need to add an additional repo that is not in our yum repository directory. The repo we want to add is the Mbari repo that is provided by Hortonworks. You will see that we have provided the current link to the latest repository given the date of this recording. However, as we have showed you in the previous sections, if you are having an issue downloading the repo because of a broken or dead link, go to www.hortonworks.com website and navigate to the installation documentation to find the latest link to the repository file. We're going to grab that text here. Once we have the link to the Mbari repository file, we will use it to install the repository. First, you will need to log into your head node in the Amazon cluster, and once you are logged in, we will use the wget command followed by the link we have to download the Mbari repo file to our current working directory, which should still be the etc yum.repos.d directory. So if we see the text that we got here, we're going to go ahead and execute it on the machine. We see that it was downloaded correctly. Run the ls command on the etc yum.repos.d directory one more time to make sure that we have the proper file copied. We see that we have it here. Now when we try to install one of the Hadoop or corresponding utilities using the yum install command, it will automatically check the Mbari repository we have just added. Simple as that. We are done. This will save you a lot of headache in the future. So to summarize this video, we gave you an overview of the different installation options for software on Linux. We utilize multiple Linux commands such as ls, wget, yum, and others. We honed in on using the yum tool along with the proper software repositories as the easiest method for getting the software we need. We saw in our video that adding a new repository is as simple as finding the most current .repo file, downloading it, and copying it to the yum's repository directory. In the next video, we will use the newly acquired Mbari.repo file to download one of our most useful tools, pdsh. Building Hadoop clusters. This is section 5, setting up configuration settings across Hadoop clusters. In the previous video, we showed you how to set up Linux software repositories so you can install the software you need using the yum utility. We went to the Hortonworks website so that we could install the Mbari repository using the mbari.repo file. In this video, we are going to install the pdsh utility from the Mbari repository. The pdsh utility will be the main utility we use to execute commands across all of the nodes in our Hadoop cluster. However, we will only install the utility on the head node of our cluster. The head node is the node we are using to install all of our software and where the Hadoop installation files are downloaded and installed. The pdsh utility is simply known as the parallel shell utility. pdsh is used to execute commands against multiple nodes. When a regular shell command such as ls is typed in after typing in the pdsh command, the pdsh utility will send the ls command to each of the nodes defined in its configuration file. pdsh is able to log into all the nodes because we have set up a passwordless SSH across our head node and the rest of the nodes in our cluster. In the previous video, we installed the Mbari repository, and now that we have the Mbari repo defined for the yum installation tool, let's use it to install the pdsh utility. First, we start off using the PuTTY utility as our terminal for accessing the head node as root user. We load the head node credentials and log in as the root user. Now that we are logged in as root, let's first double check that we have the Mbari repo file in the correct place by using the ls command. Run ls against the etc yum.repos.d directory and look for the mbari.repo file. Once you have confirmed the Mbari repo, we are ready to install PDSH. Execute the following command to install PDSH. Yum install-y PDSH. To signify that yes, we confirm to install the software PDSH and any dependencies. Since PDSH only lives in the Mbari repository, the Yum utility will automatically search the repositories it has access to and find and install PDSH. You will see a series of commands get executed through Yum, and an additional set of commands to install PDSH along with any of the PDSH software dependencies. The PDSH dependencies can include library files to other utilities. Don't worry, Yum knows how to install everything without causing any conflicts. Once this process is complete, we are now ready to configure PDSH for usage. When PDSH gets installed on your head node, it will also create a directory under etc for configuration. There is a file within the PDSH configuration directory called machines. For every host address that is listed in the machines file, the PDSH utility will send a command to all of the hosts in that file if the -a command is used. To configure PDSH, list the address of each of the data nodes in our Hadoop cluster in the PDSH file so that it can send commands to all three machines. Since we have already set up a passwordless SSH earlier in our video series, we won't have to configure any of the login aspects of PDSH and will save a lot of time. We also set up the etc host file on our system with all of the nodes in our cluster, and we will now use that information to populate the machines file in the etc/PDSH directory. Since we have all three nodes in our cluster and we know those were the last three nodes we defined in the host file, we want to add the last two to our machines file. This is because we are already logged in the head node and we will execute commands here first, then to the other two nodes in the cluster through PDSH. Before you use the following command, if you copy and pasted text from Notepad into the host file, you may have lost some special characters like the tab character. So let's go back in the host file and add the tab character in. Type vi etc hosts, and then go to the last three lines, where you see a blank space in the X letter, to delete the white space and then type I for insert mode. So we delete it, delete it, delete it. I for insert mode, press tab. Delete these. Once you've done these for all the letters, hold down the Shift key and ZZ so you can save and exit. And you got to make sure you're not in insert mode. Now type in tail-n2/etc/hosts cut-f2 etc pdsh/machines. Actually, we're going to have to do this quickly for this area. And we're all set. Go back and type that in again. Okay, just forgot one /. Reading this command out loud, first we will run the tail command against the etc/host directory file, putting out the last two lines, or in our case, the two data nodes in our Hadoop cluster. Next we will use the pipe command. The pipe command is used to redirect standard output from one command to standard input of another command. This action is also called piping the output. So let's use the pipe command to pipe data from tail to the cut command, which only takes the middle or second value, which is the FQDN, or fully qualified domain name, from the last two lines of the host file. Finally, we'll output the machines file, and in one command we'll get everything done. Now that we've correctly installed and set up PDSH, let's test it out. let's run the whoami command. The whoami command will tell you which user you're logged in as. And here we see it's root. We will run the whoami command through pdsh by issuing the following command: pdsh-a for all machines and whoami. This command will run the whoami command on each of the two other nodes in your cluster, and the pdsh utility should return a root from both machines, which we see here. If this worked correctly, you've done it and you can move on to the next section. So to summarize, we showed you how to properly install, configure, and use the pdsh utility. This will become an invaluable tool as you are forced to make many setup changes and configuration adjustments to nodes throughout your cluster. Regardless of having 2 data nodes or 50, you can use the pdsh utility in the process to scale up your installation. Coming up in the next video, we will continue making the necessary configuration adjustments, preparing our Linux operating system environments for the Hadoop installation. In the previous video, we showed you how to successfully install, configure, and use the pdsh utility. This is important because now when we want to make configuration changes to the data nodes in our Hadoop cluster, we can run a command once and have it applied many times through pdsh. We showed you how to set up the machines file for pdsh to recognize each of the data nodes in our configuration. Now that we have pdsh set up, let's use it to make the following changes to our overall Hadoop cluster. First, we are going to prep the data nodes just like we prepped the head node by setting up SSH daemon and file permissions along with the Mbari repository. Next, we will remove any known conflicting software that may pose an issue with our Hadoop installation. Finally, we will install, enable, and disable whatever services we need in the Linux operating system so we can make sure our Hadoop installation works on the first try. With that, let's get started with prepping the data nodes. The first thing we're going to want to do on the data nodes is prep from the same way we did for the head node by setting up passwordless SSH. The first step to setting up passwordless SSH is having the private key file. The private key file should be located at /root/.sh/id_RSA. Let's use the Secure Copy or SCP tool to copy the file from the head node to each of the data nodes, N1 and N2. Since we have set up N1 and N2 host information, we will not need to add any more information to make this happen. Run the first 2 commands shown here for the private key transfer. However, remember to type in the command as shown and do not copy and paste the text, as some characters may change and make the command not work. And so here we will just say scp root.ssh, and we're going to send that to N1. And we see that file was copied. Do the same thing for N2. Next, we want to set up the SSHD configuration file and restart the services. For your convenience, we have included the command here using echo to create an SSH configuration file on each data node along with the restart command. To run each of these commands across the data nodes, we will use pdsh. Place each command in text double quotes and place the command after the pdsh-a command as demonstrated here under SSH configuration. Run both commands. Okay, we'll try it one more time. And done. Finally, run the chmod command against each of the files for SSH to make sure they will be accepted. We use multiple commands here separated by a semicolon, which is equivalent to pressing the Enter key. This is so that we can run multiple separate commands per line, as shown here. So let's go ahead and just run that by itself. Okay, we executed that. Next, we want to make sure each data node set up the correct repositories for Hadoop software download. In our case, we need the mbari.repo file, and again, we have included the command here you need to execute using pdsh-a. We will use wget following by the cp command to run the Embari repo file in the correct place for the yum utility to use. Run both commands under repo setup. Okay, we have that downloaded to both. Then we're going to copy it to the proper directory. And that's done. Next, we'll want to install the Hadoop software. We want to make sure that we do not have any conflicting software packages or out-of-date versions. If you go to the hortonworks.com website, you will find installation documentation that tells you exactly which software can and cannot be installed on Linux prior to Hadoop installation. In our case, since we are using a predefined Amazon machine image, we know exactly what software exists on the machine image before we use it. Furthermore, we have cross-referenced that with the latest Hortonworks documentation that we found what we need to remove using Ruby and RRD tool. This is because we saw conflicts with these tools in the Hortonworks documentation. Here we will use the yum command to remove the software in any conflicts. When using yum, you will run the yum command followed by the erase statement. We will also include an asterisk at the end as a wild character should there be multiple names or versions for the Ruby or RRD tool. Execute the command shown here. Answer yes to confirm the erasing and wait for it to finish. So let's go ahead and do that. We say yes. We then run the command again wrapped in a pd-sh-a, but in this case we also include a -y as an auto yes confirmation to yum. This way we can send the command down as a one automatic command to each of the data nodes as shown here. The last step in our process is making sure that we've installed, enabled, and/or disabled any of the crucial system processes required for the Hadoop installation. In our case, this boils down to two key areas. One is NTP, the other is IP tables. NTP is used to synchronize the system time across each of the nodes in our Hadoop cluster. In the case of our AMI and CentOS distribution, NTP is not already installed, so let's use yum to install it. We execute the following command to install NTP on the head node. Everything should go through automatically and you will have NTP installed. Next, wrap the statement above in quotes and run it after the pd-sh-a command as we've been doing. Once this is complete, let's make sure we turn the NTP service on. You can do this by running the check config command. We type in chk config ntpd on. This will turn on the run levels for the NTP daemon, making the NTP process always start with system start. Next, we want to make sure we have IP tables both for IPv4 and IPv6 turned off. You can do this by running the following command: check config IP tables off, check config IP6 tables off. And we see there is no IP6 tables. You can also stop a running service dynamically by issuing the command service IP tables stop. Then rerun the command again with pd-sh for the data nodes. You won't need to do anything for IPv6 because the AMI doesn't have it configured. The version of CentOS we are using does not have SE Linux installed, so you will not have to do anything there. However, if you do suspect that SE Linux is installed, make sure you turn it off. The way to turn off SE Linux varies by distribution by checking the /etc directory for the SE Linux configuration file and/or executing the set enforce 0 command. To summarize, we have shown you and taken all the necessary steps to prep our cluster in the cloud for Hadoop installation. We installed Linux instances and configured them properly so that we can install Hadoop 2.0 without any issues. In the next section, we will begin the process of downloading the Hadoop software and installing the process across the servers in our cluster. Hello, and welcome to Building Hadoop Clusters. This is Section 6, Creating a Hadoop Cluster. In the previous section, we continued setting up the Linux environment in preparation to install the Hadoop software. We went through properly setting up Linux software repositories so that we could download the correct version of the software. We then proceeded to add the Embari software repository so we could install the PDSH tool. Next, we utilized the PDSH tool to send one configuration command in Linux to multiple nodes in our cluster. We finished off our preparation for the Hadoop installation by removing any conflicting software and making sure we had the proper services enabled or disabled. In this section, Section 6, we are going to finally get to download the Hadoop software and install it on all of the nodes in our cluster. Generally, the entire process of installing Hadoop, after you have prepped the nodes in the cluster, takes about 90 minutes. This includes time to actually download and install the software. Before we do that, however, we will make sure we have all of the necessary processes running on the machine. The next two videos in this section are specifically going to be dedicated to walking you through the installation and configuration process of the Hadoop cluster build. So to reiterate, in this video today, we will first make sure that we have set up the Linux environment correctly. These steps primarily occur in Section 4 and Section 5 of this video series. Next, we will move to finding the correct Hadoop software for download. Here is where we're going to make sure that everything is running correctly in the Linux environment. But before we move forward with the Hadoop installation, the first order of business is making sure that the host files are set up correctly. We can do this for each of the nodes in our cluster in the following way. First, we log in through SSH to the head node master in our cluster. We can then execute the cat command. Make sure we have H1, N1, and N2 defined. H1 is our head node, where N1 and N2 are node 1 and node 2, more specifically data node 1 and data node 2. We can then initiate this same command on these machines by executing the pdsh command, and here we have the cat of the etc-hosts/hosts. Make sure everything looks correct and the same. Now we have checked both passwordless SSH and the host file for all three machines. Next, we want to check for the embari.repo file on all machines. Let's do this in one combined statement. This will list the contents of the yum repositories directory across all nodes. This command will list the directory contents for the master and two slave nodes. Make sure we find the Embari repo on all three machines. We will want to also make sure we removed any conflicting software. Try the command yum erase -y ruby star rrd tool star on the head node to make sure it doesn't do anything and Ruby and RRD tool is already removed. Next, we check the services for all three machines. Let's once again use the combined statement. We'll check NTPD. And we see that it's running. We'll do the same thing for IP tables. We see it's not running. The other two machines didn't come back, but that's okay. We just do a PDCH. We see that the actual command brings back bad statement, but we also know that it's not running. So it gives an exit code, and we can check it right there. If NTPD is on and IP tables is off, then we should be good to go. However, if we have NTPD off or IP tables turned on, then you can use this service command to turn the services on or off. Once everything is good, you are now ready to download the Hadoop software. Now we will want to download the supporting Hadoop software to all of the nodes in the cluster, followed by downloading the Hadoop software itself. Let's start with downloading the extra packages for Enterprise Linux, or EPEL, by typing in yum install -y EPEL-release, and then we'll do the same thing on the other nodes. We're going to wait for that to complete. Once we see that this completes successfully, we want to download the Hadoop software, which we will only download to the head node in our system. To download the Hadoop software, you will do it through Mbari. This is done by typing in yum install-y mbari-server. And once this completes, we will have to remove the pdsh tool as it could conflict with the Hadoop installation. It is served as well. So let's wait for this to complete here, the Mbari installation. And then to remove the pdsh tool, we just say yum erase-y pdsh. And when this completes, let's go ahead and type in Mbari-server setup. This will ask you if you want to go into customize user settings. Press enter for no. Then it will ask you to accept the Oracle licenses and download Java. Press enter for yes. Finally, it will ask you if you want to go into advanced database settings. Again, we're going to want to use the default and press enter. When that comes back, we press enter for no. When this completes, you have now successfully downloaded and run the Hadoop installation file. In the next video, we will start installation and go through all of the configuration steps. So in this section, we quickly went through each of the Linux configuration settings. We made sure we had access via SSH to all nodes in the cluster, as well as a correct host file setup. We then checked the running services. Finally, we downloaded the Mbari binaries, which allow us to download and install the Hadoop software. We ran Mbari setup and downloaded Java. In the next section, we will go over the first part 1 of the Hadoop installation, and explain all of the steps along the process. In this video, we are going to go through the first steps in the Mbari installer to download the Hadoop installation files and set them up correctly. The first step in our process is going to be to log into the head node, master in our system. We will log in using PuTTY and the DNS address we received from Amazon EC2. Once we are logged in, we can already start the Mbari server and set it up so that it's ready to go. Type into the command line as root user Mbari-server start. This should run a set of steps in the background and then automatically start the Mbari server. Once this completes, we are now able to log into the Mbari server through the web browser. Grab the same DNS address for the head node you used before to log in with PuTTY. With this DNS address, grab it here quickly from EC2. We're going to type in http:// the DNS address you just had, followed by :8080 for the port, and this will take you to the Mbari server sign-in screen. The first thing that you're going to want to do with Mbari is log into the system. To log into Mbari server, as this is the first time we are using it, you can use the default username and password. The username is admin, and the password is admin. All lowercase letters. Once you type this in, then click sign in. Once you log in, you will see the welcome screen to Apache Mbari. Mbari is going to be the tool that allows you to install, monitor, and administer the nodes in your Hadoop cluster. The first thing Mbari is going to ask you is the name of your cluster. In my case, I will name my cluster Hadoop_3n for 3 node and cluster. Go ahead and name your own cluster and click next. The nice thing about Mbari is the streamlined interface that gives you options to install Hadoop. Here we see you can install either Hadoop 2, Hadoop 1.3, and older versions from Hornworks. If you want to go with a more stable documented version, you can use 1.3. In the case of our video, we always want to go cutting edge with our audience, and so we will utilize Hadoop 2.0. The main difference between the two versions is that in Hadoop 2.0, we can introduce the Yarn framework that allows for more capability in terms of resource management and interactive workloads in the Hadoop environment. Select your version of Hadoop and click Next. Now you're going to be asked about the installation options for downloading the Hadoop software. The first thing you will be asked is to include all of the hosts within the Hadoop cluster. Remember, we are going to need the fully qualified domain name, FQDN, which we retrieved earlier to create our host file. Let's go back to the host file on our head node and look at the values we need. You will see that we are taking the center values out of the 3 lines. And they're right here. So we copy from the VI editor in the PuTTY SSH terminal, and then paste it to the text box in the web browser for Familiarize server. Double check and make sure that you only have one host per line and there are no leading or trailing spaces or characters, and there are no extra new lines at the end. We'll remove any of extra information. Next, the Familiarize server is going to ask you about the SSH private key. In our case, this is not the version that we converted to Windows, which ends in .ppk, but the version that we downloaded from Amazon originally when we created our private key, or the one we may have recreated. Locate the .pem file you created earlier and point the Familiarize server to it by clicking the Choose File button. This should load the text underneath with the information stored within the .pem file. The next field should be auto-populated where it asks for the SSH user. This should be root. Make sure the radio button for Perform Manual Registration on Hosts is not selected. Also make sure the advanced setting for Use a Local Software Repository is also not checked. Then go ahead and click Register and Confirm. The Familiarize server will go into Confirm Host screen, where you will see 3-bar percentage graphs showing the progress on each of the nodes in the cluster. The process will go through registering, installing, then a success or failure. You should receive success, however, if you receive failure, a link will appear to the error log to show you why the error occurred. If the install is a success, you should see a link check results, which includes checks for firewall, process package, file folder, server, user, and MISC issues. Click Next and you will go to Choose Services screen. We will stop here and continue the installation instructions in the next section. So today we learned how to start up the Familiarize server, connect to it through a web browser, and log in. Next we used the Familiarize server to set up our installation options for installing Hadoop. We then configured and defined each of the nodes in our cluster, provided the private key, and proceeded to check each node in our cluster for Hadoop installation readiness. In the next section, we will choose which Hadoop services we want to install, then we will configure each service and go through the installation. In this video, we are going to go through the rest of the steps in the Familiarize installer, which includes choosing which Hadoop services we want to include and what function each serves, along with defining the configuration information and login information for each of the services. Let's start off where we last left in the previous video. We are at the screen in the Familiarize server setup that was titled Choose Services. Here you will see all of the services such as HBase, Hive, and others are enabled by default. Let's keep every service checked for installation unless you have some specific reason not to. Now let's step through each of these services and give a brief explanation of what the service is used for. HDFS. The first service is HDFS, or Hadoop Distributed File System. This is one of the core aspects of Hadoop. HDFS is where we store our files in a distributed fashion. For example, you have the common file system on Linux, which can be accessed via normal commands like cd, makedir, mkdir, etc., and have paths that start with the / command such as / etc or etc. With HDFS, we have a new file system that looks and feels like the original, with only a small subset of the original file system commands available. However, for each file that is stored on HDFS, the data blocks for that file are spread across each of the data nodes in our Hadoop cluster automatically. MapReduce. The next service is Yarn, or MapReduce 2. This is the programming framework that allows us to execute programming languages like Java in a distributed fashion, and utilizes resources across the data nodes in our cluster. Nagios. Nagios is the monitoring and alerting system that will check for health conditions on the nodes in our cluster and send alerts like emails if something happens. Ganglia. Ganglia is another type of monitoring tool that gathers metrics about our system like resource consumption, performance, and how they are being used. Hive, or HCAT. Hive and HCAT is a data warehouse system for Hadoop that gives you the RDBMS-like access to files stored on HDFS. Hive. Hive is implemented and accessed through a SQL-like language called Hive Query Language, or HQL. HCAT. HCAT or HCatalog is where metadata, format, and schema about HDFS files are stored so that you can run Hive queries or pig scripts against the files. HBase. HBase is the non-relational key value store within Hadoop, also known as one of the key NoSQL tools used to store less structured, or more hierarchical, nested type datasets. Pig. Pig is a scripting language that allows one to more easily write data manipulation processes that use MapReduce2 under the covers. Scoop. Scoop is a tool used for transferring data across Hadoop and more structured platforms, such as a Relational Database Management System, or RDBMS. Oozie. Oozie is used for the workflow scheduling and execution of Hadoop jobs. Zookeeper. Zookeeper is used for the reliable mechanism of coordination and synchronization amongst nodes and specifically required for HBase installations. There are also some other tools that features within Hadoop that you will not see here. These are some of the tools that you will find in more previous versions like Flume. Flume, which is used for ingesting, streaming, or logging data, and Mahout. Mahout, which is used for machine learning algorithms. Now that you have some background on each of the key services, let's click Next and define which services get installed on which nodes in our cluster. In the next window, you will find the screen that is defined as Assign Masters. This is where you will assign the master processes for each of the services we mentioned in the previous screen. You will want to identify your name node by its fully qualified domain name, or FQDN. If you have not memorized it, go back to the PuTTY terminal and type in hostname-f. Okay, we see ours is the 25-173, and that's the node right here. Now that you've identified the name node, make sure all master services are kept on the name node except for sname node, which can go on either of the two other data nodes. When you are done, you should have your name node with all of the master services: HDFS, Nagios, Ganglia, Hive, Hive Master, HBase Master, Zookeeper. One data node will have the sname node in Zookeeper, and the other data node will have Zookeeper. Press the Next key. The next screen, Assign Slaves, will show you all three nodes in your cluster and ask you to designate the data nodes. You will be asked to assign slaves and clients. Go ahead and check all the boxes for both data nodes. This will designate them as data nodes. Install the region server for HBase, the node manager for Yarn, and the client so that you can connect in and use the client utilities. Make sure nothing is checked for the master head node. Click Next. You will finally be left with the Customize Services screen. In this screen, you'll want to leave most everything as default. We need to change the block replication since we only have 2 data nodes and the default block replication is 3. Under HDFS Service, scroll down and find the Advanced widget. Press the down arrow and find the block replication field and change it from a 3 to a 2. Next, you will see a little red number 1 next to areas that require your attention. This will be Hive, Oozie, and Nagios. Hive and Oozie will require you to define a password, and Nagios will have you define an email and password. Take note of the usernames for each of these services. Go ahead and fill in your password and email, and click Next. Finally, before you start installation, you will get a chance to review the settings. Go through and make sure they are okay. Then click Deploy. Generally, the process will take about 45 minutes and go through installation and checks of each service. If you have any errors, make sure you click the link to check the error logs and search in the Hortonworks forums for any known issues. In summary, we have shown you how to download, install, configure, and deploy a Hadoop cluster. Coming up in the next section, Section 7, we'll show you how to use and understand HDFS, the Hadoop Distributed File System. Hello and welcome to Building Hadoop Clusters. This is Section 7, Loading and Navigating the Hadoop File System, or HDFS. In the previous section, we checked whether all of the necessary processes and files prepared in the Linux environment before Hadoop installation. After making the necessary checks, we went ahead and downloaded the Ambari server. With the Ambari server, we were able to download Hadoop and run the installation package. The installation wizard for Hadoop through Ambari took us through a series of configuration steps. We configured and installed the server. So now you should be to the point where you have 3 large Amazon EC2 nodes with Hadoop 2.0 running. In this section, we are going to start playing with Hadoop and look at some of its core features and how to use them. More specifically, we are going to use Hadoop's distributed file system, or HDFS, to store files across the 3 nodes in our cluster. We will begin by providing you with a background about the HDFS system, how it works, and what its architecture looks like. We will follow the basics with the aid of a real-world example of downloading data to your Hadoop cluster and then distributing that data in HDFS. We will also look at some of the commands and how to navigate the HDFS directories. We will then conclude this section by giving you a detailed overview of the Ambari dashboard. The Ambari dashboard, the same one you use to install Hadoop, provides a rich interface on top of Hadoop from the Ambari interface. You'll be able to access all of your Hadoop monitoring and alert interfaces such as Nagios and Ganglia. Ambari will also provide you with an overview of what jobs are running on your system and how resources are being affected. By the end of Section 7, you will be able to understand the HDFS architecture, download files to your Hadoop cluster, and understand how to monitor for any performance issues. Now on to understanding the Hadoop file system. Back in 1999, Google was faced with the problem how to index the World Wide Web. In 2003, Google released a white paper about how to solve this problem with distributed file systems. Google called it Google File System. The Google File System paper explained how to deliver a system that lived across servers and over a network. Google delivered the concepts and methodology to build a distributed computed system that could scale in both processing power and disk storage capacity, even for a single file that could be petabytes in size. After this white paper, Doug Cutting at Yahoo and a team of developers at Yahoo developed the open source Hadoop technology that creates HDFS based on Google File System along with MapReduce. Now that you have a background on how Hadoop was started, let's talk more about HDFS. HDFS allows you to store files in a Hadoop cluster, such that files are distributed across the data nodes. So in our cluster, this would be the 2 data nodes. Not only are the data blocks of each file spread across the data nodes, but they are also replicated based on the replication factor setting. If you take the example of a single file made of 90 data blocks, all data blocks will be distributed across the 2 data nodes in our cluster. The replication factor replicates copies of each data block to different data nodes, so that if one data node goes down, the data is still available. Typically, the replication factor parameter is set to a default of 3, which replicates a data block so that there are 3 copies. However, in our case, since we only have 2 data nodes, we set the replication factor to 2 during our initial installation. So if we take our example with 90 data blocks, and if the replication factor is 2, then another 90 data blocks will be spread, resulting in approximately 90 blocks total per data node, or 100 blocks total, 180 blocks total, 90 for the original, and 90 for the replicated copy. This has 2 advantages. You are not limited to the storage of data on just one server, but 2 in our case, and you can scale to more servers as you grow out your Hadoop cluster. You now get high availability against node data failure. 2. Data locality. Each portion of the file that's stored on each server has a server CPU close to disk storage, in most cases direct attached storage, allowing you to scale up the processing speed on any given file. The HDFS architecture is such that the name node in your cluster will store metadata about your files in HDFS, such as the file name. And then each of the data nodes in your cluster will store the actual data blocks of the file. Since the name node stores files, name information in memory, there is a limit on the number of very small files that you can store as a result of memory constraints. You will also have to factor the overhead of other master processes living on the name node. The HDFS system is also built and optimized for batch-style processing. Typically, Hadoop is not used for interactive queries. However, with the introduction of Hadoop 2.0 and the Yarn framework, Apache has decoupled the MapReduce processing and the resource management so that interactive usage is attainable. Another thing to keep in mind is that once an HDFS file is created, you cannot modify a file at arbitrary points, and can only do appends, or create a new file when writing new data to disk. Let's take an example here of a single 256 megabyte file that we want to store on Hadoop's DFS, or Distributed File System. Metadata about the file is stored on the name node and includes info about the file size, number of blocks, etc. Then, based on the HDFS block size, which is a default of 64 megabytes, we will split the file into blocks and spread across the data nodes. For a 256 megabyte file, we have 4 data blocks. In our cluster, since we have 2 data nodes, 2 blocks may go to data node 1 and 2 blocks will go to data node 2. Also, depending on the replication factor, which is a default of 3, but in our case will be 2, we will spread other replicated set of blocks to the alternate data nodes. So in this section we cover the topics we will discuss in section 7. Specifically in this video we discuss HDFS in detail. We covered all of the key aspects to be aware of when using HDFS and how data is stored in the overall architecture. In the next section, we will go over how to navigate and access files in Hadoop, as well as downloading and copying files to the cluster. Hello and welcome to Building Hadoop Clusters. This is section 7, Loading and Navigating the Hadoop File System. In this video, we are going to get hands-on and navigate across the HDFS directories. We will show you all of the basic commands that allow you to create, manipulate, and administrate files that live on HDFS. Then towards the end of the video, we will show you how to download a file from an external host to the data node's local Linux file system. Next, we will execute a command that loads that file and distributes it across HDFS. Let's get started. The first thing that you want to do is connect to one of the data nodes in your Hadoop cluster. In our case, when we are going through the installation of Hadoop, we only check the client utilities to get installed on the data node and not on the name node. But we did this for both of the data nodes. So it should not matter which one you connect to, but do note it for future reference. If during installation we installed the client tools on the name node, we could also use some of those client tools on the name node as well. Here we're going to connect to data node 1. So we're going to load up the SSH client and load the configuration settings that we have been using to connect to the name node in our cluster. Here we called it H1, we'll say load. This time we're going to replace the IP address with one that we have for the data node 1. We can grab the IP DNS information from the EC2 dashboard as we did before, and we replace it within the configuration settings. So let's go to the first data node, grab the DNS information, and then here for the IP address, we're going to fill it in with the new information. We then click Save, changing the instance name to Hadoop Data Node 1. And then click Open. Once we are connected, let's set up our environment, and we're going to run some tests. Create the following directory using the makedir command. Makedir/root Hadoop_tests. Next, we check to see if we have access to the Hadoop command line utilities. The first command you will want to run is a simple ls command against HDFS. Try the following: Hadoop fs-ls and the root directory. We see that works fine. This command is executing the Hadoop file system command, and it'll list the contents of the HDFS root directory under /. The HDFS file system has much of the same commands and semantics as when dealing with the common Linux file system, albeit a very small set of commands. To get a full list of commands that you can execute against the Hadoop file system, just type in Hadoop fs, and you'll be presented with a list of possible file system commands that you can execute against HDFS. You can also type in Hadoop fs-help for a more detailed explanation of each command's capabilities. If you try to use the Hadoop command for creating a directory, which is the same, makedir or mkdir, you will see that root does not have permission to any of the directories in HDFS. This is because in the HDFS world, the HDFS user is the super user. We will use the HDFS user to create a directory, and then we will allow full permissions on that directory so our root user can access it. Again, this may not be the ideal setup for production purposes, but at least it will allow you to quickly start playing with Hadoop and HDFS and not have to worry about setting up all the security permissions correctly. You can worry about that later. Let's build up the use case now. So our first step is make a directory for the root user and another for our Hadoop test under the /user directory in HDFS. Let's first do sudo sudo-u, so we're going to be the HDFS user. We're going to issue the Hadoop fs command. We're going to create a directory with mkdir, and we're going to call it user/root. This command has an execute the Hadoop fs command for makedir as the HDFS user and creates the parent root directory under user. We still don't have access yet. Next, let's make sure that our root user has access to create and edit files in this directory. We then execute sudo -u hdfs hadoop fs -chmod 777 user root. This command should now give our user access to the HDFS directory /user/root. Let's test that by creating the Hadoop_test subdirectory, corresponding to the same directory we have on local disk. This time, however, we are going to create the directory as root user. Execute the command hadoop fs -makedir /user/root/hadoop tests. This should create the directory and will check and make sure that you have the proper permissions. Finally, let's download a sample file and copy it from the local disk on data node 1 to the HDFS system that distribute across the data nodes in the cluster. In our example, I will download a list of DVD movies and corresponding information that is pipe delimited. This dataset is only about 50 megabytes uncompressed. On my Amazon EC2 node, it takes only a few seconds to download. Before you go ahead and download on the data node, make sure you have enough space. You can do this by executing the following command, df-h. Here we see we have 4 gigabytes available, which should suffice. Make sure that you're in the root/root/hadoop test directory. On the local file system, not in HDFS, and then execute the wget command as a Mozilla web browser user, and the link to this is www.homethéater.info.com/download/dvd_csv.zip. But you can download from any location that you have a file. In this case, we need to use the wget.u option because this website only allows browsers to download the file. Hence, we submit a user agent as Mozilla or Firefox. Then unzip by running unzip dvd, the name of the file, which will generate a file called dvd_csv.txt. Finally, once we have the file we want to copy to HDFS, execute the Hadoop fs command, copy from local to get it there. We end with executing Hadoop fs -copy from local, noting the case sensitivity, dvd_csv.txt. We're going to send that to user root Hadoop_tests in our HDFS directory. That file is copying over now. Then we execute Hadoop fs ls user root Hadoop_tests, and we confirm that that file is there, and it is. So in this section, we have shown you how to navigate and do basic tasks against HDFS through the command line interface. In addition, we downloaded a simple pipe delimited file to the local file system in the data node and then transmitted to HDFS using the Hadoop fs command copy from local. In the next video, we will cover the Ambari dashboard in detail so you can understand exactly how to monitor and configure the system. We will also run a smoke test, which will test all of the components of the Hadoop stack in your cluster, which you can do one by one, and make sure that everything is working correctly. In this video, we will complete the section on the Hadoop file system and cover administration by focusing on the Ambari dashboard. The Ambari dashboard provides an extremely rich set of analysis tools for configuration and administration. You will learn how to use Ambari to monitor the system resources across your cluster, make Hadoop system configuration changes, and run service checks to verify whether Hadoop services are working as expected. Let's first start with showing you how to navigate Ambari. Though Ambari provides a rich interface for monitoring the system, keep in mind there are also command line tools you can use as an administrator. Let's begin by opening the web browser. If you haven't already, you should navigate your web browser to the default Ambari server. This is the DNS address of your name node, followed by :8080. You will either be automatically logged into Ambari dashboard, or you will require to be logged in. Remember, the username and password are both admin, lowercase. Once you're logged in, let's make sure that you have a better password. Click on the admin tile in the horizontal menu bar and click on the edit under action for admin user. Here you will be able to change your password. Let's go ahead and change that to something more unique now. Make sure to keep your password handy but in a safe place. Then click on Save. Now let's test our new username and password by clicking on the User Account button towards the upper right hand corner. This is also says Admin, and selecting Sign Out. Sign back in with your new password. Okay, now we are back into the Mbari main page, or dashboard. Let's take a look at some of the metrics we can follow here. You will see that we have many metrics about our cluster, from HDFS capacity to the status of data nodes, CPU, network, memory usage. Also notice that if you hover your mouse over one of those metrics, for example HDFS capacity, it will show you more details about the metrics it is displaying, like how many gigabytes exactly are being used versus what is available. Some of the widgets in the dashboard will have the mouse turn into a directional cursor when you hover the mouse over the widget. This means you can move the widget. If it turns into a magnifier, as in over the network usage, then you will be able to see a zoomed in graph of activity. Also, some widgets let you see a little pen and pad icon that appears in the widget's upper right hand corner. This signifies the ability to customize this particular widget, such as setting an alert or color thresholds. The key metrics to examine at first glance in this dashboard are HDFS capacity, so that you know you're not running out of space, data nodes to make sure if any data nodes are live or down, CPU, memory, and network usage to see where you may be experiencing a bottleneck, and finally name node RPC, so you can get a general idea of load on the name node of the system and what the response time is for simple calls, such as a hang event or a larger load. The other widgets can be useful, but for more specific reasons. For example, the HBase widgets, if you are experiencing issues or congestion with HBase users, which may require lower latency and response times. The next set of information is under the Heat Maps tab. The Heat Maps tab displays the usage of different components of Hadoop over time. In particular, the data is displayed as a heat map, which means that periods of higher or warmer activity will show a reddish orange, as opposed to periods of inactivity or colder, which will typically show the system as available and is green. Since we have not had this cluster online running for a long time, the heat map does not convey meaningful information for us at this time. Once the cluster has been running longer, and especially for capacity planning or performance troubleshooting, the heat map becomes extremely valuable. This is because it will let administrators easily identify periods where capacity is constrained, or when the system may be experiencing some type of bottleneck due to the type of job that is running on the system. The next set of information is under the Services tab. Click on the Services tab and you will see some very detailed information about the HDFS component of Hadoop. We get a list of all the alerts and health checks. Here we see everything has checked out. Next, we have a summary about all of the important metrics of HDFS, such as number of files, number of blocks, uptime, etc. Finally, below these two dashboard widgets, you will see another set of metrics specific to HDFS that go above and beyond what you expect in the simple Mbari homepage dashboard. Next, you will see a tab at the top next to Summary, but still within the Services page, that says Configs. This will let you directly manipulate the Hadoop configuration files for HDFS, and this is the proper way to make those changes through Mbari when the services are turned off. Finally, there's one more tab called Quick Links, and will provide you with all the links and components of HDFS, or whichever particular service outside of Mbari. You will typically see this set of links and information for each of the services in Hadoop, such as Hive or Ganglia. Click on any one of those services on the left to use them. Finally, before this video section, let's go ahead and run a service check. The service check will test each component that is highlighted. In our case, HDFS is in focus. We will do an HDFS service check. Click on the Service Action button on the upper right hand corner next to the Start and Stop buttons. Then choose the option to Run HDFS Service Check. The test should automatically run and give you a result. If everything runs correctly, you should see a success screen with a green check mark and green status bar. If you lose the dialog screen of what's running in Ambari, you can always go back and check the status of Ambari at the top left corner where it mentions the name of your cluster. If you have any new alerts, you will see a little number next to this button here. To conclude, in this section we discussed the ins and outs of using Ambari. We examined how to use the dashboard to find out details about each service. Finally, we ran each service to check to make sure HDFS was running correctly. In the next section, our final section 8, we will cover installing Apache Hue, which is the open source Hadoop user interface. Hello, and welcome to Building Hadoop Clusters. This is the final section, Section 8, Hadoop Tools and Processing Files. In the previous section, we examined the Hadoop Distributed File System, or HDFS. We discussed the background architecture and how it works. We then proceeded to download a file and show you how HDFS can distribute that file across the nodes in our Hadoop cluster. We then looked at the Ambari dashboard, which is our main window into monitoring the running Hadoop services. We then covered all of the different dashboards and performance resources. We wrapped up the sections by running a Hadoop service check on the HDFS, which verifies that the HDFS component in our Hadoop stack works correctly. In this section, Section 8, we are going to wrap up our video course on Hadoop with the final application that you will want to use on top of the Hadoop stack. This application is known as Hue, or more commonly known as the Hadoop UI. Hue allows you to put a GUI-like interface on top of your Hadoop components such as Hive. This will allow you to easily load and query tables as well as run other Hadoop components without having to memorize a command line interface. This section is broken down into 3 components. In the first part, we will need to install Hue as it does not come bundled with Ambari Hadoop. We will then discuss an overview of the Hue components. Finally, we will do a sample run where we load a file in Hue, define its schema, and then query it through Hive. In this video, we will begin the processing of installing Hue. To install Hue, we will need to first shut down all Hadoop services, configure files, then download and install the Hue software. Let's get started on the Hue installation. The first thing that you're going to need is to turn off your Hadoop services if they are running. Go to your Ambari server. First, we open a web browser and navigate to the head node and port 8080 to get to your Ambari server. If you've completed your installation and you aren't logged in automatically, go ahead and log in with your admin password or the password that you change it to, and then we go to the Services tab. Once in the Services tab, you will see a button in the lower left-hand corner, a big red button that says Stop All Services. Go ahead and click that button. No need to worry, we can always turn them back on whenever we want. You will get a confirmation screen. Click OK. Then go ahead and watch as the Hadoop services turn off. This can take about 10 to 20 minutes depending on the size of the machines in your Hadoop cluster. Again, we are using large. Once we have turned off the Hadoop services, we will need to make some changes to the Hadoop configuration files. We can only do this when the Hadoop services is turned off. You first need to edit the core-site.xml file, which is under HDFS services. If you aren't already there, click on HDFS service. You will see a Configs tab. Go ahead and click that. You will see options near the bottom for Advanced to update the custom core-site XML file. We want to go to the custom core-site XML file and add in the Hue hosts and groups. Click the down arrow, then click Add Property. A pop-up dialog will appear, and then you will want to input the key. The first key is for the hosts, and you will want to add hadoop.proxyuser.hue.hosts. And for the value, put in an asterisk. This will allow you to configure the user Hue as a proxy for all other users and groups. The next value that you will want to add to core-site.xml is the groups for Hue. We will add close to the same text that we just added in the key value pair, but replace hosts with groups. Go ahead and click on Add Property and add the line hadoop.proxyuser.hue.groups and then an asterisk for the value. When we use the asterisk value here and previously, it implies that any user or group will be allowed access into Hue if they have a password. You will need to revisit this value when you decide to deploy Hadoop for production purposes, as it can be a potential security risk. You will also see the following two values already defined in core-site.xml with Hadoop proxy user hcat groups and Hadoop proxy user hcast hosts. Change both of these to an asterisk. Okay, now we will need to add properties to the hdfs-site.xml file, which is just below the custom settings of core-site.xml. Here again, click on the down arrow. Next, click on Add Property here for the key that you will need to add. And here you'll want to add in dfs.support.broken.append, and then put in true for the value and click Add. We will also want to make sure that Web HDFS is enabled. If you check under the General tab, you will see a check mark for Web HDFS enabled. Make sure it's checked in your version as well. It usually is by default. Finally, click on the Save at the end, and you should get a pop-up saying everything was saved successfully. Next, we will need to make some slight modifications to MapReduce. Click on MapReduce 2, then click on the Config tab. Go down towards the end of the page, you will see the custom mapred-site.xml file. You will need to click the down arrow, and then you will need to click the Add Property as well. And for the key value pair, in the key you're going to put in jobtracker.thrift.address, and you're going to have that equal to 0.0.0.0:9290. Click Add. Then click on Add Property again. And this time you're going to input for the key mapreduce.jobtracker.plugins, and that's going to be equal to org.apache.hadoop.thriftfs.thrift.job.tracker plugin. And notice the case sensitivity here at the end. Finally, click on the Save button to save the MapReduce 2 settings. Next, we will need to make slight modifications to Uzi. Click on the Uzi service on the left, then navigate to the Config tab. We want to add some values for the uzi-site.xml file. Go down to where it says Custom uzi-site.xml file. Click on the down arrow, then Add Property. And then for the key value here, we're going to want to add uzi.service.proxyuser.proxyuser.hue.hosts, and the value for that is going to be an asterisk. Click on Add. You will also need to do the same for the groups. Click on Add Property one more time, and for this time we're going to add in uzi.service.proxyuser.proxyuser.hue.groups and an asterisk again. Click on Save to save the Uzi configuration settings. And finally, you will also need to make changes to Web HCAT. Go ahead and click on Web HCAT. Go to the Config section and down to Web HCAT-site.xml. Here we're going to put in Add Property. And for that property, we're going to add Web HCAT.proxyuser.hue. That's going to be an asterisk. And then one more is going to be web hcat.proxy_user.hue.hosts asterisk. We have that set in. And we are all set in terms of having the Hadoop configuration for Hue after we save that for web hcat. To summarize, we learned about the Hadoop interface Hue. Before we can start using Hue, which gives us a GUI interface into Hadoop components, we need to install it. This is because Hue does not come packaged or configured with Hadoop by default. In this video, we covered the first half of setting up Hue, and we looked at changing configuration files in Hadoop, which may come in handy later on one of your adventures with big data. Coming up in the next video, we will continue with the Hue installation. We have to install the Hue utilities, make some more changes to the system, and then finally start Hue services on top of Hadoop so we can start using it for our last section. In this video, we are going to continue with the Hue installation and focus more on the installation of the Hue components, along with any changes we need to make to Hue configuration files. Starting the services and logging in. Let's get started. We will want to start with installing Hue components. We need to choose one of the nodes to install Hue on. Hue is an application that will run on any one of the nodes in your cluster, or even on its own separate server. Hue provides, which stands for delete word, and it will delete all of the text for localhost. Then click on the I button, guys, and the user login credentials to submit a job. Since this is for test and development purposes, we will also want to keep things simple. Let's go ahead and install Hue on the head node as we have installed all of the interfaces. In a more robust setting, or if you can go with 4 or more servers, you can use a secondary node for the sname node, Ambari server, Hue components, and others. To install Hue on the head node, we will need to log in directly into the head node, so let's go back and connect through the PuTTY terminal. Log in, choose the head node, and then get login as root user. From the previous video, all of the Hadoop services should still be turned off. To install Hue, we just type in yum install Hue-plugins. It will ask for confirmation. Type Y and hit enter. It will go through the Hue installation for the plugins. Next, we will want to install Hue, so type in yum install Hue. Type Y for yes and click enter. And it'll go through the installation process. Now that we have Hue installed, we will need to make sure that the configuration file for Hue is set up correctly. All of the parameters are set by default are correct. However, we will need to make changes to the location of web HDFS address to have it work properly. To do this, go ahead and edit the Hue configuration file. Open it up via the VI through the following command: vi/etc/hue/conf/hue.ini. This will go into the VI editor, and then we will want to find the line where a web HDFS is defined. Hit the / button so we can search. Search for web HDFS and hit enter. This should find the correct line. Where you see localhost, you'll need to replace it with the internal hostname for this node. You can get this information if you do not have it immediately by getting the public DNS address through EC2. If I open up the web browser and go back to EC2 and click on the head node, you will see the public DNS that I can use. Go back to the terminal after you've copied the address, move the cursor over to localhost, and press the letters DW, which stands for delete word, and it will delete all of the text for localhost. For insert, and it will insert the address that we copied previously after we press the paste button. Press escape to exit insert mode, then hold and press Shift plus the Z button to save and close VI. Once we have configured Hue, the Hue ini file properly, let's complete our Hue setup by setting up the correct privileges. Type in the following command line: vi sudo This will allow us to access a pseudo file and give Hugh access. Next, add in the following lines by copying first, going to the end of the file, pressing the O button, and then typing in the following for the Hugh users. Hugh all equals all. Hugh all equals all no pass WD sbin and check config, and then we're going to copy that, do it again for service, paste that again, and this time instead of sbin it's going to be bin, and we're going to put in kill. And then that's it. Press escape to get out of insert mode. Again, shift ZZ to escape and save. Now that Hugh is set up, let's go back to start our Hadoop services. And we go here. If you do not have your browser open up already, go ahead and open and navigate it to the Embari login. Go to services. And you'll see here the start all button. Go ahead and click that. It should take a little bit of time to start up your Hadoop services. Once the Hadoop services has started up, let's go back to the terminal services, the terminal screen through PuTTY, so that we can start Hugh. And you'll type in service Hugh start and press enter. You should see Hugh loading up and checking the Hadoop components, and the last line should let you know that the Hugh service is okay. To test if Hugh is working correctly or not, let's go ahead and access Hugh through the web service. Hugh uses the same address that we had using for the Embari service, but this time from a different port. Navigate to your web browser and to the same address that you used for the head node, but with the following port. Instead of 8080, we're going to use 8000. This will take you to the Hugh login screen. When you log in for the first time into Hugh, you will need to set a username and password. Here we will need to use the HDFS as a username because HDFS is the only user that has super privileges in HDFS. So go ahead and use HDFS and then use your own custom password. Just make sure that you write your password down and go ahead and click sign up. And we see that we logged in here. Once in the Hugh login screen, you will see multiple icons that you can click on towards the top of the screen. Each of the components of the Hadoop stack like Hive and Pig. And if you see a little red icon next to any of these components, then it signifies that Hugh encountered an error connecting to one of those Hadoop components. To summarize, in this video we completed the installation of Hugh. We went through installing all of the components in the terminal window, and we logged in through the web interface and created a unique user. In the next and final video, we will use this user through Hugh in the next section to create a table and run a query through Hive, based on the data that we downloaded previously in section 7. We will then spend some time at the end reviewing all of the content that we have learned throughout the video series, and what new tools and skills you now possess that can be deployed. In this video, we are going to end our video series with a practical application of using Hadoop and the Hugh interface. We will use the file that we have previously downloaded and distributed across HDFS in section 7. We will use this file as a basis to define a structure for DDL within hcatalog Hive, and from there we will then write a query in Hive, all executed through the Hugh interface. Let's get started. Let's go to the Hugh interface, and if you do not have it open already, go ahead and click on hcatalog in the top bar. Here you will need to create a table from a file. If you remember from our previous section, section 7, we downloaded a file and copied it to /user/root/Hadoop_tests, the directory that we created. Let's use that file for hcatalog. Click on the Create a New Table from a File. You will go to a screen that will ask you for a table name and description. The file I downloaded had DVD information, so I will name it here accordingly. We see here that hcatalog allows us to choose a file from HDFS. So let's go ahead and choose that file. under user root Hadoop tests, we have the dvd_csv-text file. So go ahead and click that. And we'll see that hcatalog automatically looks at the file and parses it for us, giving us all the information we need and some sample rows from that file. We see that it was automatically picking a delimiter and a coding and everything else that we need. So go ahead and create table. And you'll see here in the background is creating that table. Okay, so we wait for that to happen. Okay, so table got created. Now it's importing data into the table. So going through the processes in Hadoop to get this table and the file created. And as soon as we get this table created and that's finished, we're going to go ahead and click into Hive and then run a query against it. And now we see that the table got created, DVD info. So let's go ahead and click over to Hive. And within the Hive query editor, we can select all of the rows from that same table that we just created from Word keyword. So let's put that in, execute that, and here you go. Here is all of the rows executing a Hive query against the file that we just downloaded. Automatically has all the headers and everything done for us within Hadoop and Hue. And so there you have it, a simple example of using the Hadoop interface to create a table from an HDFS file and query it using Hive. Now let's take a moment and cover all of the topics we discussed and gained knowledge on in this video series. In section 1, we covered a general overview of the topic of deploying Hadoop 2.0 utilizing cloud technologies. The majority of the time was spent learning about Amazon instances and how they work. Section 2 was dedicated to network and security settings, and we showed you how to set up security groups on Amazon, as well as utilizing encryption security technologies with public and private keys. The next section, Section 3, was dedicated to connectivity with cloud instances on Amazon when using a Windows client. We learned how to use the PuTTY utility to connect to cloud instances and PSCP, which uses the SCP or Secure Copy Protocol to transfer data to those cloud instances as well. In Section 4, we connected to the head node of our Hadoop instance and started the arduous process of preparing our environment for Hadoop installation. This included setting up passwordless SSH and defining the host file. In Section 5, we continued the process, defined and verified the correct Linux software repositories, and made sure the correct services were running or disabled in some cases. In Section 6, we finally had our chance to start installing the Hadoop cluster using Ambari and made sure that everything was in proper order. In Section 7, we finally had Hadoop installed, as well as learn how to download and distribute a file in HDFS, and also run a smoke test for all of the core components in Hadoop. And finally, we end here in Section 8, where we have added the Hadoop interface Hue on top of Hadoop, and also gone through a real-world scenario where we defined the file we downloaded in Section 7 and queried it through Hive. In summary, you have learned 2 key skills that will give you a technical edge in the workplace when it comes to big data. Number 1, you are now an expert in deploying Hadoop 2.0 clusters on the cloud. No matter whether it's another version of Hadoop or another type of cloud, you have the basics that you need to get the job done. Not only that, but the method and the approach we took scales as well. So whether you're installing a Hadoop 2.0 cluster with 3 data nodes or 50 data nodes, you know how to handle it. Number 2, you are now able to install the Hadoop user interface on top of Hadoop 2.0 clusters and query data that you loaded into HDFS through Hive. This gives you the power not only to create Hadoop systems, but also use them for analytics and get answers to big data questions. So thank you for taking the time with me to go through the full 24 videos, or over 2 hours of our video series. We hope you found it helpful. I am your author of the content and narrator of this video series, Sean Mita, and can be found on LinkedIn in the displayed link. Thanks.